Welcome to this video on Node.js design patterns. Here, we are going to explore common patterns and best practices for Node.js development, focusing on building scalable and maintainable applications. Design patterns are reusable solutions to commonly occurring problems in software design. These are time-tested approaches that solve recurring design challenges, improve maintainability, readability, and scalability. The Singleton Pattern ensures a class has only one instance and provides a global point of access to it. This pattern is useful for managing resources like database connections, loggers, and configuration objects. Here's an example of how to implement the Singleton Pattern in JavaScript. We have a class database connection with a static instance property initialized to null. The getInstance method checks if an instance already exists. If not, it creates a new instance and stores it in the static instance property. Finally, it returns the instance, ensuring only one instance is ever created. The module pattern encapsulates code into reusable modules with public and private methods. This helps prevent global namespace pollution and provides a clean API interface. Here's an example of the module pattern in JavaScript. We have a user service module that uses an immediately invoked function expression, also known as an IIFE, to create a private scope. Within this scope, we declare a private users array. The module returns an object with public methods, such as addUser and getUsers, which can access and manipulate the private users array. The observer pattern defines a one-to-many dependency between objects, so that when one object changes state, all its dependents are notified and updated automatically. This is commonly used in event handling systems, real-time data updates, and model view architectures. Here's an example of implementing the observer pattern in JavaScript using the events module. First, we require the events module. Then we create an order service class that extends event emitter. The createOrder method simulates processing an order and emits an order-created event with the order data. Finally, we create an instance of order service and attach a listener to the order-created event, which calls the handleOrder function when the event is emitted. The factory pattern creates objects without specifying their exact classes or construction logic. This promotes loose coupling between components, makes it easy to extend with new types, and centralizes object creation. Here's an example. We define a logger factory class with a static createLogger method. This method takes a type parameter and returns a different logger instance based on the type. For example, if the type is file, it returns a file logger instance. If it's console, it returns a console logger instance. If no type is provided, it returns a default logger instance. The middleware pattern involves a chain of functions that process requests in a sequential pipeline. It is commonly used for authentication and authorization, logging and error handling, and request/response modification. Consider this example. We define an auth middleware function that checks for an authorization header in the request. If the header is missing, it returns a 401 unauthorized status. Otherwise, it calls the next function to continue to the next middleware in the chain. We then use this middleware in an express.js application using appuse before defining the route handler for /API/users. The strategy pattern defines a family of algorithms and makes them interchangeable at runtime. This allows you to swap algorithms dynamically, easily add new strategies, and eliminate conditional logic. Here's an example. We define a payment processor class that takes a strategy object in its constructor. The processPayment method then calls the pay method on the strategy object. We can create different strategy classes, such as credit card strategy, and pass them to the payment processor to change the payment method at runtime. Here are some asynchronous patterns and best practices. Async await is used for writing clean, readable asynchronous code. Proper error handling with try-catch blocks helps ensure graceful error recovery in asynchronous operations. Promise.all is used to execute multiple asynchronous operations concurrently for better performance. Stream processing helps handle large data efficiently and optimizes memory usage. Here are some key takeaways from this video. Design patterns provide proven solutions for common Node.js challenges. Choose the right pattern based on your specific use case and requirements. And focus on maintainability, scalability, and code clarity. Happy coding! If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.